June 13th, 1944. A concrete observation bunker, 50 feet beneath the Normandy cliffs near Port-en-Bessin. The air smells of wet earth, diesel fuel, and stale cigarettes. General Lieutenant Dietrich Kreis, commander of the 352nd Infantry Division, presses his field glasses against the reinforced viewing slit. For 7 days, he has watched the American beachhead at Omaha expand like a slow hemorrhage across his once pristine killing fields. But this morning, something has changed. Something impossible. Through the layered haze of cordite and sea mist, Kreis sees not the supply chaos Rommel predicted. Not the floundering invasion his Führer assured him would drown in its own logistics. Instead, he sees structures, massive, angular silhouettes rising from the steel-grey English Channel, where only waves should exist. Concrete towers, steel gangways, a city of stone and metal materializing in the surf like some Arthurian legend summoned by Eisenhower's sorcerers. Mein Gott, whispers his aide, Major Heinrich von Bismarck. The aristocratic Prussian's voice cracks with a note Kreis has never heard before. Not fear, not exactly, something worse. The sound of certainties collapsing. This is the moment the Atlantic Wall became a monument to German miscalculation. This is the instant the war in the West began to slip irretrievably through Hitler's fingers. This is the story of the Mulberry harbors, the engineering miracle that Eisenhower would later call the most decisive innovation of the invasion, and which German intelligence dismissed as Anglo-Saxon fantasy until reality itself betrayed them. To understand the shock in Kreis's bunker, we must travel back 30 months, to the autumn of 1941, when Hitler, flush with his conquest of Europe, ordered the construction of what he named the Atlantic Wall. Field Marshal Erwin Rommel, assigned to inspect it in late 1943, found a Potemkin fortress. Of the 15,000 supposed bunkers, fewer than half were armed. Mines were scattered thinly. Obstacles were incomplete. But Rommel understood something fundamental. He didn't need to stop the invasion at the waterline. He needed to drown it in the follow-up, destroy the landing craft, channel the tanks into killing zones, but most critically, deny the Allies any port, any harbour, any place where cargo ships could dock and disgorge the 20,000 tons of supplies per day needed to sustain an army in the field. The enemy must be annihilated on the beaches. Rommel wrote in his diary on January 28th, 1944. If we can hold them for 1 week without resupply, their own logistics will become their executioner. This conviction hardened into doctrine. German war games in early 1944, played out at the 7th Army headquarters in Le Mans, assumed a single grim scenario. Allied landings at the Pas de Calais, followed by a desperate rush for Cherbourg, the only deep-water port in Normandy. If Cherbourg fell, the games concluded. France would fall within 90 days. If Cherbourg held, the invasion would starve within 60. On April 17, 1944, Hitler himself addressed his Western commanders at the Berghof. The enemy's greatest weakness is his supply chain, the Führer declared, his voice rising with certainty. Without a port, his magnificent army becomes a mob of hungry men with expensive weapons. What none of them knew. What ultra-intercepts and French resistance reports had failed to reveal was that the Allies had no intention of taking a port. They were bringing their own. The genesis of the Mulberries lies not in a military staff college, but in the mind of a 69-year-old former First Lord of the Admiralty who remembered Gallipoli. In 1917, Winston Churchill had watched the Dardanelles campaign fail, partly because of the impossibility of landing supplies on hostile beaches. "Do not let us do it this way again," he scribbled in the margins of a 1941 invasion planning document. By 1942, Churchill's memo had become Project Mulberry. The name itself was chosen at random from a list of code words, but it would become synonymous with a particular species of audacious engineering. The initial concept was deceptively simple. Create a portable harbour, break it into modules, build it in England, float it across the Channel, sink it in place off the invasion beaches, use it to unload ships. Simple to say, almost impossible to do. The mathematics were brutal. To sustain the invasion, Supreme Headquarters Allied Expeditionary Force SHAEF calculated they needed to land 7,000 tons of supplies per day by D-Day plus 15. By D-Day plus 30, 12,000 tons. By D-Day plus 60, the full 20,000 tons Rommel had dismissed as impossible without a captured port. Each Liberty ship carried about 7,000 tons. Each LST landing ship, tank, carried about 300 tons. Without a harbour, both would have to beach themselves at high tide, discharge cargo onto smaller landing craft, then retract on the next tide. The process was slow, dangerous, vulnerable to weather. SHAEF planners estimated it would take 72 hours to unload a single Liberty ship this way. They would need to unload 10 per day. The solution emerged from 3 parallel engineering miracles, each designed by a different team under the direction of Major Alan Beckett of the Royal Engineers. First, the Phoenix caissons. 200 feet long, 60 feet wide, 60 feet high. Each weighed 6,000 tons when empty. When flooded, they weighed 26,000 tons. They were, in essence, hollow concrete boxes built in dry docks along the River Thames and the River Clyde. 6 of them. Then 12. Eventually, 147. Each required 8,000 cubic yards of concrete, 400 tons of steel reinforcement. They were built in total secrecy behind camouflage netting, their true purpose known only to a handful of engineers and a few curious swans on the river. Second, the bombardons. Massive steel cruciform structures, 200 feet long, designed to float on the surface and break up waves before they reached the harbour. 48 of these would be needed. Third, the pier system, codenamed Wales. This was Beckett's masterpiece. Standard bridging technology couldn't handle the channel's 12-foot tidal range. Beckett designed a floating roadway. 72 steel spans, each 80 feet long. They rode on pontoons that rose and fell with the tide. Trucks could drive from ship to shore on a road that moved like a living thing. The roadways were named spuds, after the potato-like shape of their buoyancy chambers. 160 spuds would support the Wales. All told, 1.5 million tons of concrete and steel. 150 individual components. 600 tugboats, barges, and self-propelled units required to tow them across the channel. In March 1944, Eisenhower visited the construction site at Southampton. He stood on a half-finished Phoenix, staring into its cavernous interior, and said nothing for 5 minutes. Finally, he turned to Beckett. "Major, if this works, you'll have shortened the war by 6 months. If it fails, your name will be a footnote in the history of our defeat." Beckett, a quiet civil engineer from Manchester who had never fired a shot in anger, replied simply, "It will work, sir. The math says so." The invasion began on June 6th. By dawn on June 7th, the first Phoenix caisson was already underway. They came in slow convoys, 6 knots, the speed of a walking man. The first caisson, designated A1, departed from the Daffodil Yard at Stokes Bay at 0630 hours on June 7th. It was towed by 3 tugs, the Danube 4, the Thames 4, and the Clyde 1. The crossing took 36 hours. The channel was still littered with wreckage, bodies, unexploded mines, the burned hulks of landing craft. Caisson A1 arrived off Omaha Beach at dusk on June 8th. The beachmaster, Captain James Hughes of the United States Navy, had prepared the site. Divers had surveyed the seabed. Shallow holes had been dredged. At precisely 2100 hours, the caisson was positioned and valves were opened. Seawater flooded the internal chambers. Slowly, with a groan of compressing air and the hiss of water, the 6,000-ton concrete box settled onto the sandy bottom, 35 feet below the surface. The process was repeated. Again. And again. By June 10th, 12 Phoenixes formed the outer breakwater of Mulberry A at Omaha. By June 12th, 24 more enclosed Mulberry B at Arromanches, serving the British and Canadian beaches. The whale piers came next. Each 80-foot span was lifted by floating cranes vessels named London 1, London 2, and London 3. The spud pontoons were positioned with surveyors using theodolites, ensuring the roadway would fall at exactly the right angle. The bombardons were anchored in a semicircle 1,500 feet offshore. On June 13th, the day General Kreis pressed his field glasses to the viewing slit, the American Mulberry A was 70% complete. The British Mulberry B was 80% complete. What the Germans saw was this. Where there had been only surf and sand on June 6th, there now stood a breakwater of concrete towers. Ships were docking. Cranes were swinging. Trucks were moving on a steel road that seemed to float on water. It was as if the Allies had brought a piece of Southampton to France, and they had done it in 7 days. The Germans knew about the Mulberries, or rather, they had known of something like them. In March 1944, Abwehr agents in Southampton reported unusual construction activity along the riverbanks. Photographs showed concrete boxes, steel sections. The reports were filed under bridge-building exercises. No one connected them to invasion planning. On April 3rd, a Luftwaffe reconnaissance aircraft overflew the Portsmouth harbour. The pilot's photographs clearly showed Phoenix caissons being fitted out. The Luftwaffe intelligence officer, Major Hans-Joachim Licht, wrote in his analysis, "The enemy appears to be constructing breakwater sections. Possible use for protecting anchorages in England. No strategic significance." Even when French resistance workers reported massive concrete structures being stockpiled at British ports, the German High Command dismissed the intelligence. Ports were fixed. Harbours were permanent. You could not move them across the sea. The very idea violated the physics of logistics as the German General Staff understood it. Rommel himself had received a memo on May 20th, 1944, from the 15th Army Intelligence Section. It mentioned possible portable harbour components, but carried a handwritten note from Rommel's Chief of Staff. General considers this technically implausible. Steel and concrete required would exceed British production capacity for 6 months. The General was wrong. The British had not built these components in 6 months. They had built them in 18. They had diverted cement from hospital construction. They had requisitioned steel from railway projects. They had employed 17,000 workers in 24-hour shifts. The cost, in 1944 pounds, was $25 million. In modern terms, roughly $1.2 billion. But the true cost was measured in something more precious than money. It was measured in the certainty of German commanders who, on June 13th, stared at Omaha Beach and saw their calculations dissolve like mist in the morning Sunday. Let us descend from Kreis's bunker to the beach itself. Let us walk onto Mulberry A as it functioned on June 14th. The first Liberty ship, the SS Charles W. Worcester, nudges against Pier 3 at 0800 hours. Her draft is 28 feet. In any normal beach landing, she would have to anchor 3 miles offshore and transfer cargo to lighters. Here, at Mulberry, she ties up directly. Her stern lines are made fast to bollards welded onto the spud pontoons. Her bow is held by 2 tugboats. She rises and falls with the tide, but the pontoons rise and fall with her. The relative motion is 0. A crane, the barge-mounted derrick No. 4, swings its boom over the ship's hold. It lifts a 2-ton crate marked 105 mm ammunition. The crate travels through the air for 80 feet and settles onto a waiting 2.5-ton truck on the Whale roadway. The truck moves forward 30 feet. Another crate is lifted. The truck, now full, drives shoreward. The roadway flexes beneath its weight, the spuds bobbing in perfect synchronization. Behind the Worcester, the SS John Steele waits its turn. Behind that, the SS Thomas R. Roosevelt. 8 ships per day, each unloading in 6 hours instead of 72. The cargo is not just ammunition. It is gasoline in 5-gallon cans, stacked 8 high on pallets. It is sea rations in wooden crates. It is jerry cans of water. It is medical supplies, field telephone wire, spare parts for tanks and bags of mail from home. At Pier 2, a different scene. LST 389 beaches itself at high tide. Its bow doors open. Its ramp extends onto the Whale roadway. A Sherman tank, weighing 33 tons, rumbles ashore. Then another. Then a column of 300 jeeps, trucks and half-tracks. By low tide, LST-389 will retract and return to England for another load. It will make this trip every 3 days for the next month. On the beach itself, the traffic is orchestrated by beachmasters with bullhorns. Vehicles move in one-way lanes marked by painted barrels. At choke points, military police direct traffic with semaphore flags. The entire system is a ballet of steel and manpower. The statistics accumulate with brutal efficiency. June 14th, 5,000 tons landed at Mulberry A. June 15th, 7,000 tons. June 16th, 8,200 tons. By June 18th, 3 days before crisis, superiors at 7th Army Headquarters will fully accept the reports. The Americans are landing 10,000 tons per day. The German defenders watch from their cliffs. They have no counter-battery fire capable of reaching the harbours. Their aircraft, what remains of the Luftwaffe in France, cannot penetrate the Allied fighter umbrella during daylight. At night, when raids are possible, the harbours are invisible, their outlines broken up by paint schemes and camouflage netting. The German 88mm guns, the most feared anti-tank weapons in the world, are useless against concrete walls 12 feet thick. The German mortars, the infantry's hip pocket artillery, cannot range the 1,500 yards to the pierheads. The German machine guns, which cut down GIs by the score on June 6th, now fire impotently at cranes and trucks that move beyond their effective range. It is not just a logistical triumph, it is a tactical victory. The Mulberries have stolen the entire littoral zone from the Wehrmacht. The beach, which Rommel had turned into a killing ground, has become an Allied sanctuary. Nature, for a moment, takes the side of the Germans. On June 19th, the barometric pressure over the channel begins to fall. By noon, winds are gusting to 35 knots. By evening, they reach 50. The storm builds through the night, peaking on June 20th and 21st. Waves 20 feet high crash against the Phoenixes. The bombardons, designed for 15-foot waves, are overwhelmed. They snap their moorings and drift away like children's toys. The spuds, anchored to the seabed with chains rated for 20 tons of strain, see forces exceeding 40 tons. They begin to break free. The whale roadways, those elegant floating bridges, twist and buckle under the dynamic loading. Mulberry A, the American harbour at Omaha, takes the brunt. The storm comes from the west, and Omaha faces the open Atlantic. By dawn on June 21st, 6 of the 12 Phoenixes have cracked. Their internal bulkheads, never designed for twisting forces, have failed. They fill with water and sink into the sand, not as breakwaters but as broken concrete. The whale piers are gone. The spuds have been cast ashore like driftwood. Only the SS Charles W. Wooster remains, now beached on the sand where LSTs had landed 2 weeks before. Her hull is cracked. She will become a total loss. The British Mulberry B at Arromanches, protected by the Cotentin Peninsula, survives with 70% functionality. But the Americans are back where Rommel wanted them, beaching ships directly onto the sand. Here, the documentary could end on a note of tragedy. The engineering marvel, destroyed by nature. The German hope, restored by weather. But that is not what happened. On June 22nd, as the storm subsides, Brigadier General William H. Big Willie Morris, commander of the American Engineer Special Brigade, lands on Omaha Beach. He walks through the wreckage. He sees the fractured Phoenixes. He sees the tangled steel. He sees the exhausted soldiers trying to salvage what they can. He turns to his aide, Captain Robert P. Bob Miller, and says, "We didn't need the fancy harbour anyway. We need to unload ships." The insight is brilliant in its simplicity. The Americans had been using the Mulberry as a conventional harbour, ships dock at piers. But the pier system was the fragile part. The Phoenix breakwater, even shattered, still created a protected anchorage. Inside that anchorage, LSTs could beach themselves safely. They could discharge directly onto the sand. They could work around the clock, not at the whim of tides and surf. Morris's engineers begin salvaging the spuds. They rebuild the whale roadways in abbreviated form, reaching only to the 5-fathom line. They create a hybrid system. The surviving Phoenixes provide shelter. The beached LSTs provide the platforms. Trucks drive into the surf at low tide to meet them. By June 25th, 3 days after the storm, throughput at Omaha is back to 5,000 tons per day. By June 30th, it is back to 8,000. By July 10th, it reaches 12,000 tons per day, 20% more than the original Mulberry was designed to handle. The Germans, watching from the cliffs, see the wreckage. They report jubilantly. American harbor destroyed. 7th Army Headquarters distributes champagne. Rommel, visiting the front on June 24th, sees the broken concrete and allows himself a rare smile. The enemy has built himself a fine reef, he tells his staff, but the supply flow does not stop. If anything, it accelerates. The Americans have abandoned the pretense of a harbor and embraced the reality of a highly organized ship-beaching operation. The British, at Arromanches, continue using their intact Mulberry B, which will eventually land 2.5 million tons of supplies before the war ends. The German champagne goes flat. The intelligence reports become confused. How can supplies continue to land if the harbor is destroyed? The answer, which they cannot comprehend, is that the harbor was never the point. The point was the system. The system had redundancy. The system had adaptability. The system was, in the truest sense, American. Let us pause the narrative and examine the arithmetic that so shocked the German officers. Numbers, dry on paper, but devastating in their implications. Between June 6th and June 30th, the Allies landed 518,000 soldiers in Normandy. They landed 110,000 vehicles. They landed 570,000 tons of supplies. Of this total, 43% came through the Mulberry harbors. The rest came via direct beach landings, but the Mulberries made those beach landings possible by reducing congestion and providing sheltered anchorages. By July 24th, when Operation Cobra, the breakout from Normandy, began, the daily tonnage had reached 23,000 tons. This was more than the entire German 7th Army consumed in a week. It was more than Rommel's entire Panzer Group West had available for its entire operational area. The statistics of construction are equally staggering. The American Mulberry A, even in its damaged state, required 843,000 man-hours to install. The British Mulberry B required 1.1 million man-hours. The casualty rate among the engineers was 3% higher than the casualty rate among the assault troops on some beaches, because the engineers worked continuously, in daylight, in exposed positions, while the infantry had the relative shelter of foxholes. Material costs: 120,000 tons of steel, 670,000 cubic yards of concrete, 500 miles of welding rod. Enough paint to cover 500 acres. But the crucial number, the one that made German officers like Kress physically ill when they read the intercepted ultra-transcripts, was this. The Allies had achieved in 7 days what the German General Staff believed would take 7 months. They had built a port where no port could exist. They had made the impossible routine. Behind every ton of supplies was a human story. Let us follow one crate, selected at random from the manifest of the SS John Steele, on June 15th. The crate weighs 120 pounds. It contains 1,000 rounds of .30 caliber ammunition for the Browning automatic rifle. It was manufactured at the Remington Arms plant in Bridgeport, Connecticut, on March 3, 1944, by a woman named Mary O'Donnell, a 34-year-old mother of 2 whose husband is serving in the Pacific. She works the 4 to midnight shift and takes the streetcar home in the dark. The crate is loaded onto a boxcar at Bridgeport on March 5th. It travels by rail to the port of New York, where it sits in a warehouse for 6 weeks while manifests are matched and priorities assigned. On April 20th, it is loaded onto the John Steele, a Liberty ship built in 38 days at the Bethlehem Steel Yard in Baltimore. The ship's captain is a 49-year-old merchant marine veteran named Thomas Anderson, who has not been home to his farm in Minnesota for 11 months. The John Steele crosses the Atlantic in a convoy of 42 ships, escorted by 4 destroyers. The crossing takes 18 days. The convoy is attacked twice by U-boats. 1 escort destroyer is sunk. The John Steele does not stop. On June 14th, the ship arrives off Omaha Beach and ties up at what remains of Pier 3. The crate is lifted by Seaman First Class James Robertson, a 19-year-old from Macon, Georgia, who was a tractor mechanic before the war. He places it on a truck driven by Private First Class William Bill Martinez, a 22-year-old from Los Angeles, whose grandfather fought with Pancho Villa. Martinez drives the crate 3 miles inland to a supply depot. From there, it is transferred to a 3/4-ton truck driven by Corporal Henry Hank Schmidt, a 23-year-old from Milwaukee, whose parents emigrated from Bavaria in 1923. Schmidt delivers the crate to Fox Company, 2nd Battalion, 16th Infantry Regiment, 1st Infantry Division, the Big Red One. The crate is opened by Sergeant John Jack Riley, a 25-year-old from Boston, whose father was gassed in the First War. Riley distributes the ammunition to his bar team, Private Thomas Tommy Donnelly, 20, from Philadelphia, Private Robert Bobby Walsh, 19, from Chicago, Private Michael Mickey O'Shea, 18, from Brooklyn. On June 17th, Fox Company attacks the German strongpoint at Colleville-sur-Mer. Donnelly fires 600 rounds from his BAR. The weapon does not jam, not once. The ammunition, manufactured by Mary O'Donnell in Bridgeport, transported by Captain Anderson across the Atlantic, handled by Robertson, Martinez, Schmidt, and Riley, functions perfectly. The German defenders, short on ammunition because their own supply lines are cut by Allied air power, cannot match the rate of fire. The strongpoint falls. Tommy Donnelly will survive the war. He will return to Philadelphia and become a firefighter. He will never know about Mary O'Donnell or Captain Anderson or the Mulberry Harbor that made his ammunition supply possible, but he will always remember that his bar never jammed, not once. And in that simple fact lies the entire story of the Mulberries. They made the complex system work, so that the simple things like a rifle firing when you pull the trigger became reliable. By July 1st, the shock in German command posts has turned to something darker, fatalistic acceptance. General Dolman, commanding 7th Army, writes in his war diary, "The enemy's ability to supply his forces has exceeded all calculations. We must now consider our position untenable without immediate reinforcement, but reinforcements cannot come. The Mulberries, by enabling the Allied build-up, have created a tactical situation where German reserves cannot reach the front. The roads are interdicted by Allied aircraft. The railways are destroyed by bombing. The few units that do move by night arrive piecemeal, exhausted, without their heavy equipment. Field Marshal von Rundstedt, the supreme commander in the West, sends a message to OKW Oberkommando der Wehrmacht in Berlin on July 3rd. It is encoded by the Enigma machine, which the British read before the Germans decode it. The message reads, "Enemy supply capacity at beaches indicates preparation for major offensive. Recommend withdrawal to prepared positions east of Orne River." Hitler's response, dispatched within hours, is characteristically unequivocal. Not 1 meter of ground will be surrendered. The enemy's so-called harbour is a propaganda trick. His supply situation must be desperate. It is not. On July 4th, the Americans celebrate Independence Day by landing 30,000 tons of supplies at Omaha alone. The next day, July 5th, they land 32,000. The Germans, monitoring radio traffic, hear American units requesting not emergency rations but ice cream, not medical supplies but baseball equipment, not ammunition but bottled Coca-Cola. These are not the communications of a starving army. They are the communications of a force so logistically secure it can afford the luxuries of home. The psychological impact on the listening German troops is devastating. Morale, already fragile after D-Day, begins to collapse. On July 17th, Rommel is strafed by an RAF Spitfire while driving near Saint Foy de Montgomery. He is wounded, evacuated, and will die by forced suicide 3 months later after being implicated in the July 20th plot against Hitler. His last coherent order, issued from his hospital bed, is to defend every position to the last man. But his men no longer believe in the possibility of victory. They have seen the Mulberries. They have seen the supplies flowing like a river they cannot dam. The Mulberry harbors were never intended to be permanent. They were a wartime improvisation, a stopgap. Yet their influence on civil engineering would be profound. After the war, Major Alan Beckett, the designer of the whale pontoons, became Britain's leading expert on floating bridges. His concepts informed the design of the temporary bridges that would replace those destroyed in the Great North Sea Flood of 1953. The principles of flexible, buoyant roadways influenced the design of the Lake Washington Floating Bridge in Seattle. The concept of modular, prefabricated port facilities became standard practice in disaster relief operations. In the Netherlands, civil engineers studying the Mulberries would develop the first movable storm surge barriers, the Oosterscheldekering, the Maeslandkering. These massive structures, designed to protect against North Sea floods, use the same principle as the Phoenix caissons. Hollow concrete boxes that can be flooded or pumped dry to adjust their position. In Japan, post-war reconstruction of ports destroyed by Allied bombing used Mulberry-derived techniques to expedite shipping. In the United States, the Army Corps of Engineers incorporated the lessons of rapid assembly into their mobile harbor system, still used today to create temporary logistics hubs in combat zones. But perhaps the most significant legacy is conceptual. The Mulberries proved that logistics could be weaponized. That engineering was not support to strategy, but strategy itself. Eisenhower's Chief of Staff, Lieutenant General Walter Bedell Smith, wrote in his post-war memoirs, "The invasion was won on the beaches, but the campaign was won at the Mulberries. They transformed our greatest vulnerability into their greatest strength. October 1st, 1944, the port of Antwerp has fallen. Real harbours are now available. The Mulberries, their job done, are being dismantled. The surviving phoenixes at Arromanches will be left in place, becoming permanent breakwaters for what is now a French fishing port. The American Mulberry A, or what remains of it, will be salvaged for scrap. The steel will be recycled into Liberty ships. The concrete will be crushed for roadbeds. General Lieutenant Kreis is dead." He was killed on June 16th, 3 days after he first saw the Mulberries, when an American artillery shell struck his command post. He never lived to see the full impact of what he witnessed through his field glasses. But his aide, Major von Bismarck, survived captivity and returned to Germany in 1947. In his unpublished memoirs, written in old age, he describes that morning of June 13th. "We had prepared for everything. We had prepared for tanks. We had prepared for paratroopers. We had prepared for chemical weapons and flamethrowers and every horror of modern war. But we had not prepared for engineers. We had not prepared for men who could build a city in a week." In that moment, watching the concrete towers rise from the sea, I understood that we had already lost. The numbers are final. Mulberry A, despite its destruction, enabled the landing of 1.8 million tons of supplies. Mulberry B landed 2.5 million tons. Together, they handled 4.3 million tons in 120 days of operation. This represents 41% of all Allied supplies landed in Normandy before the liberation of Antwerp, but numbers cannot measure the strategic shock. The Mulberries invalidated 3 years of German defensive planning. They rendered the Atlantic Wall obsolete before the cement in its bunkers had fully cured. They proved that the industrial might of the United States, when married to the engineering genius of Britain, could create logistical capacity ex nihilo out of nothing. In Berlin, OKW conducted a post-mortem in December 1944. The report, declassified in 1962, contains this sentence: "The enemy's artificial harbours represented a failure of imagination on our part. We could not conceive of a solution so vast in scope, so precise in execution, and so rapid in deployment." This failure of imagination cost us France. The story of the Mulberry harbours is not merely a tale of engineering prowess. It is a meditation on the nature of modern warfare. In the 20th century, wars would no longer be won solely by the bravest soldiers or the cleverest generals. They would be won by systems, by logistics, by the ability to move not just men, but the entire material universe those men required to survive and fight. The German officers who pressed their field glasses to bunker slits in June 1944 were products of a military culture that valued tactical brilliance above all. They had studied Cannae, they had studied Leuthen, they understood envelopment and penetration and the killing power of the combined arms team, but they had not studied the industrial mobilization of democracy. They had not understood that behind every American soldier stood a workforce of 10. Behind every British tank stood a factory that could replace it faster than it could be destroyed. Behind every Mulberry caisson stood a society that had learned to build complexity at scale. The Mulberries were the physical manifestation of a deeper truth. The Allies could afford to build a port and abandon it. They could afford to construct 1.5 million tons of concrete and steel for a 4-month operation. They could afford to imagine solutions that were, in the precise sense of the word, unimaginable to their enemies. This is why the shock Crace felt was not just surprise at a clever trick. It was the horror of recognizing an asymmetry of imagination. The Germans had imagined how to defend the coast. The Allies had imagined how to reinvent the concept of a coast itself. In that asymmetry lay the outcome of the war. Today, the remains of Mulberry B still stand off Arromanches. They are barnacled and rusted, home to gulls and cormorants. Tourists sail around them in pleasure boats, snapping photographs, unaware that these concrete boxes were the keystones of liberation. They are monuments not to violence but to organization. They are the architecture of victory, built not by conquerors but by engineers who understood that the most powerful weapon in modern war is not the bomb or the bullet, but the system that delivers them. On June 13, 1944, German officers watched the Americans build a city in the sea. What they were really watching was the future arriving, a future where logistics is strategy, where engineering is courage, where the ability to build becomes the ability to win. The harbours are gone, the war is over, but the lesson remains. Never underestimate an opponent who can build a miracle from concrete and steel, and do it in 7 days. Because that opponent is not just fighting a war, they are redefining the possible.